Okay, let's get started here. So assignment number 4 is due Friday, April 3rd at noon. Also, our presentations start on April 16th. I thought that now will be a good time to decide on who's student number 2, who's student number 3, who's student number 4, and so on. So what I've done here, create a little R program where, well, first of all, Sean has already volunteered to be student number 1. But I have the remaining 7 students, their names listed here in my student.name vector. And then what I'm going to do is essentially sample without replacement from these names. And the first student who is then selected in this sample then becomes student number 2. The next student becomes student number 3, and so on. And so that in the end, I will summarize this all right here, where I have the student numbers listed, I have the date that you're presenting on, and also I have then the corresponding names of the students there. Now, in order for this to be fair, of course, you know, I want this to be essentially a random sample here. Using the sample function that we've all seen already in the Bootstrap section. So in order to do this, I need a seed number. Does someone want to volunteer a seed number? So of course I can reproduce my results.
I do have a quick question before.
Okay.
Is it final? Will this be final?
Yeah,
because,
this will be final.
I might have an issue on April 21st, so.
Okay.
That's the only
I wouldn't be surprised that the second person on April 16th would probably let you switch with them if needed.
Sure.
So if at random it just so happens you're assigned to April 21st, I recommend first talking to the second person on April 16th. Okay? Okay, so does someone want to volunteer a seed number here? 1, 2, 3, 4. 1, 2, 3, 4. Ooh. Good way to choose a seed number. Now, if you don't like your ordering here, you know who to blame. Okay? So, let's go ahead and run some of this. I guess before I run it here, you know, if you're feeling lucky, I could change the replace equal false to replace equal true. So we're taking essentially a true bootstrap resample. Of course, what that means, though, is that you could.
So some people wouldn't have to present at all.
That's right. So if you're feeling lucky, I could change this to true, but then again, you might have to do 2 or 3 presentations.
That could get boring.
Well, no, you would have to be a different topic.
3, oh, okay, 3 different
Yeah,
topics.
so I mean, if you guys are feeling lucky, I would change it to true.
No, we don't feel so lucky.
Okay. Okay, so let me. Robert, are you sure about 1, 2, 3, 4? Do you want me to change it? Or?
That was just the first thing that came to my head. But
I mean, I don't want you to get blamed for something that.
the next thing would be my birthday.
I always
but,
pick
I mean,
birthdays or
yeah,
anniversaries.
it's either my birthday or 1, 2, 4.
Well, since you said 1, 2, 3, 4 first, we'll go with that. So, you guys ready?
Sure.
Here we go.
Yeah.
So Dola is on April 21. Well, what was the probability of that happening? We could easily figure that out.
That's what I
2
was
divided by
wondering.
7, essentially. So if you wanted to switch with Francis, you could. You can talk about maybe after class. You're ready? Okay to switch? Are you okay? Well.
Well, yeah. I would have preferred a later date, but if that's the only thing that we can do.
Well,
that's fine.
I mean, if this is.
I can also talk with Robert, but I don't know if he's willing to do that.
Well, how about this? That you can all communicate.
Sure. Yeah.
Okay, and if you want to make change, just let me know. Just don't wait too long.
Oh, yeah, I'll do it today.
Yes.
The way this is, you want, like, so for April 21st, then I would go first and Dola would go
Yeah,
second.
yeah,
Okay.
yeah.
Just wanna make sure. All right.
Okay, so everyone's written down their date.
Mhm.
So I don't want there to be any confusion when it comes around to, let's say, April 21st, and you say, oh, I thought it was actually April 28th. No. Make sure you do write down your date. And again, if other people want to change by chance, that's okay.
Is the 16th is a Thursday?
Yes.
Okay.
Okay. So let's see now. Are there any questions before we get started here today? So we were talking about high performance computing. Make sure my spell checker is off.
How long did you say you thought it would take for us to get?
We actually just talked about it right
Okay.
before you got here, before class started.
Okay.
There was some problems with them emailing me saying my okay for each
Oh.
individual student.
Okay.
That has been resolved as of this morning, so I would anticipate things will start moving more quickly.
Okay, great.
Okay. So anyway, so we were talking about high performance computing. Specifically, we were talking about how to use Linux on Tusker and Crane. And here's a diagram that we saw last time that essentially shows the directory structure on both Crane and on Tusker. Note that if you do say something on Tusker, it's not on Crane and vice versa. But each of them follow the same structure here. They both have Linux operating systems, and how you use one is essentially exactly the same as how you would use the other one. And so when you first log in to Tusker or Crane, you're right here in this hierarchy. So you're under Home, your group name, which would be Stat Tools, and then your username, like for me, would be just simply Building. Now, in order to run our programs and stuff, people at Holland Computing Center, generally speaking, want you to actually be in a different directory when you do that. There are some reasons why, which we'll kind of talk about later today. And so what you need to do is change directories. So what you could do to get from, let's say, your username up to the group name under Home is go cd ... That will put you up one, cd ... again, up to Home, and then you can keep on going up to root, and then you can traverse over to work, group name, username again. So this is where you should be running your programs, right here. Now there's a quick way to make that change. If you do cd $ and then in capital letters work, that will automatically get you over there. Okay. So I've already logged on to Tusker here. Let me get back to where I need to be. So again, using ls allows you to see all your folders and stuff. Now, if you want to, let's say, make a new directory, all you need to do is use the command mkdir for make directory, and then give it a name. Let's call it temp2, so that if I do an ls again, I can see that now I have a directory called temp2. If I want to go into temp2, I'd say cd temp2. If I want to remove this directory, I can do rmdir for remove directory, temp2. And now you can see it is gone. If you want to remove a file, you can type rm, the file name. If you want to copy a file, you can use the cp of, function. If you want to move a file, you can use mv. We're just going over here to my notes here. And then if you want to, let's say, maybe just print the contents of a file to your screen, you can use the cat function. Okay, so that cat function should sound familiar because you use that in R if you want to print something to your screen or inside of R console. You use the cat function. If you want to maybe just look at, let's say, the first 6 lines of a file, use the head function, -6. Remember how often you have various options that you can do with a command, and you always have to do, usually you have to do a dash and then the various command name or something like that. Well, head -6. You've seen the head function before in R as well. So, remember that S in R was originally actually developed in a Linux environment or Unix environment. And so that's why you see some of the names that you have seen in R also now appear in Linux. If you want to look at the last 6 lines in a particular file, use tail-6. A star can be used as what's called a wildcard. So for example, if you notice here, I have a lot of hello world files. So if I want to maybe just take a look at the various files that start with hello, I can say ls hello asterisk, and I didn't do it right. Didn't I do right? Maybe I should look at my notes more closely. The H needs to be capitalized, and now you can see that through this wildcard, I'm able just to look at a portion of my files that I have on Tusker. If you want to just see all of your R programs, you can say ls asterisk dot R, and now I see I have 4 R programs that are stored there. Okay. So now page 24. Now once you get a password from the Holland Computing Center, it'll probably be something that's just not necessarily recognizable or easy to remember. And so if you want to change it, you can use the passwd command to make that change. A very interesting command on Tusker is this module command. And if you go with the option avail for available, you have a listing then produced of all all software programs that are available to you to use. Okay, so in my list here, and this list has really gotten a lot bigger over the last year since I last taught this. And on my list here, look at what's down here. R. So R is available to you. So that's nice. And 3 different versions are available to you. Typically just use the newest one, 3.1 in this particular case. But there's also a ton of other software programs available to you. I keep on paging down, page 25, look at this, SAS. So a couple years ago, SAS was actually installed on the computers there. So note that you don't have to pay for SAS at all. You could actually just simply use it on Tusker. In fact, I think that's what now a former professor over in the psychology department, that's how she used to have her students use SAS in her PhD level quantitative methods class. Now the way that you would use SAS and the way that we're going to use R is different from the way that most of you have used SAS and R in the past. Basically what you will have to do is submit a pre-written program that you've written, and then what will pop back out to you once the program's done is the output into a new file. And you'll see how that is done later today. So don't be expecting a nice, enhanced editor in SAS popping up when you try to use SAS. That won't happen. More on that as we go along. Let's take a look at some of the other programs that are available to you. And again, these are essentially all available to you for free. All you need is an account on Tusker and Crane. So for example, Mathematica, MATLAB, M+. Does anyone know what M+ is? It's a statistical software package written by social scientists. I've never used it before, but I know a number of social scientists who have. Let's see now. One that, when I was looking over my lecture notes last night, one that really interested me was something called Breakdancer. Does anyone know what breakdancer is? Okay, I had to look it up. It's basically something I think what people in bioinformatics will use. I just found that interesting to see that name because, while probably a lot of you were not alive when this occurred, but breakdancing was quite popular in the middle 1980s. I was never involved in it, but I distinctively remember right when I saw that name. When I was in 8th grade, we had to give demonstration speeches. So in my English class, we had to do a speech where you had to demonstrate some stuff. And we had some of our students demonstrate breakdancing. And so we had to move all the furniture out of the way so they could do their little spins on the classroom floor and stuff. And it's more than what you probably want to know, but I had a good laugh last night when I was looking through all this. We also have Python. Open bugs. Does anyone know what open bugs is? Okay, it's often used with Bayesian methods. We have Ruby. Remember that was one of the languages that I suggested that presentation could be done on. CUDA. Does anyone by chance know what CUDA is? CUDA allows you to work with graphical processing units. Oh, let's see now. A lot of interesting names. Shrimp, Espresso. How do you come up with some of these names? So I thought there was a few more. Java. And so there's a lot of stuff that's essentially available to you that's for free. Oh, and also there is a C++ compiler. Let's see that right there. So if you wanted to use C++, you have an option to do that. Okay. Now, similar to R, in case you don't know this already, well, in R, if you want to, let's say, in your R console window, obtain the previous command that was run, what you would do is hit the up arrow. So in Linux, if you do the up arrow, I get my previous command. And I can keep on cycling through all my commands that I've done, going back in time, you could say, using the up arrow. To go forward in time, I use the down arrow to eventually get to a point where you're just at the command prompt. That can be very useful because we're going to have to submit various commands here, often more than once, from the command prompt here. And instead of having to type something out that's pretty long, you can just use the up arrow to get what you just did. So I do find that quite useful at times. Let's say that you wanted to actually edit a document on Tusker. The way that you can do that is to use a program called Nano. So if I say Nano, let's just do my Hello World program, which we will be more fully talking about shortly. So if I say Nano, my file, there is a very limited editor that you could use to edit your document. So if I want to insert a whole bunch of spaces, I just hit spacebar. I cannot use my mouse to navigate around in it. I would have to use my arrow keys. Or I can use some information that's down here to help me navigate. So that # Y corresponds to use the Control Y sequence that will allow you to page down or go, or I guess go to the next line. Excuse me. You see some other options down below. If you want to save your file after you've done some editing to it, do a Control O. And if you want to exit it, Control X. So I'm going to Control X. It asks me, well, do I want to save my changes? No. So I hit N. There we go. Now that can be useful in particular if you want to do like a really quick change to something that's already on Tusker. What I typically recommend you do instead is, and this is what I would do. Let me actually get into the right folder here, sorry. Oh, there we go. What I would recommend that you do is actually find your, maybe you ran a program on Tusker and you realize, okay, you want to make a change. We'll find the program that you had already put on Tusker that you had uploaded. So I'm in FTP here, or WinSCP, and just drag and drop it back over to your Windows environment and then edit it from there. I think that's easier if you have a lot of stuff to do. I rarely use Nano now, but every once in a while it does come in handy. Just an interesting side note, 20 years ago when I was using Linux, I basically used Nano to type all of my email messages. That's what we had available to us. That was the only way we could do it. Okay, so let's keep on moving down here. There's a command called top. Right, so if I do top, enter, you can see my screen's going to change. And what this shows me is all the programs that are running right now on the node that I am logged into. So for example, you see me up here. I'm running the top command. Okay. Some other people, somebody's running Perl right now, whomever that person is. Now you typically don't need to really worry about what other people are doing. Instead, you just want to focus on, well, what are you doing? So I'm going to hit Q to get out of there. And if I do top, and again, I'm going to issue an option here, -U, meaning user, and I put my username builder there. Now I can see just the programs that essentially I'm running right now. So again, you can see top. The SSH corresponds to a secure shell. That is telling me that I'm logged in via PuTTY. The SFTP corresponds to my WinSCP program that I'm logged into right now, my FTP program. And then bash, again, we are using basically a bash a window in order to communicate with the operating system. So that's why you see those things listed there. Again, or I guess also I should mention here. So notice you see under you see CPU. That says, well, how much CPU am I taking up by simply running top? You can see it's very little. If you take a look at the S here, that corresponds to, well, what's a particular program actually doing right now? R stands for running. Top is running right now. My S there is sleep. I'm not necessarily actually doing anything right now on FTP or PuTTY, essentially, so that's why you see those sleeping. So I'm going to hit Q to get out. Okay, so page 28. Just some other commands you can take a look at on your own. When you're all done, just simply and PuTTY, you can type exit or log out, and that will automatically close your window. Okay, so my purpose here with this Linux introduction was just to give you enough to move around comfortably on Tusker and Crane so that we can run our programs. You know, I try to minimize the amount of commands that I give in the Linux environment, because as you can see, you have to remember what the command is first of all, and you know, that's just simply not as user-friendly as being able to use point-and-click stuff. So I try to do as much on my own computer first, and like write my program. I then upload it to the supercomputer, and then I will type some commands, which you'll see shortly, to run it. That's basically what you need, what generally speaking most statisticians need to know about this kind of a user environment. You know, depending upon what you do, sure, you might need to know more in other cases too. Now I do want to point out that in terms of the presentation topics, one thing I said was you could look into Linux in more detail. And so you could do that in the Crane or the Tusker environment. You know, look at, well, what would be, again, useful for a statistician to know beyond what I presented here. Or what I think might be even a more interesting presentation is that you could actually simply install Linux on like a USB drive, or you can install it on an SD card and run it from your Windows-based computer. Now you might be thinking, okay, well, you know, still, who wants to use Linux in this kind of archaic text-based environment? Well, in case you don't know this, there are lots of different other versions of Linux out there that essentially try to mimic what Windows does, in terms of you have windows that pop up and stuff like that. So, and all those, or many of them, of those versions of Linux are free. So you can download it, install it on a USB drive, install it on an SD card, doesn't matter which. And what you can do is explore in terms of what's available to you. In all those environments, though, you would be able to access a bash window or something similar to it. So you can still do exactly what we've done here, just like the command prompt in Windows. But then you also have the advantage of being able to use R essentially in a Windows-based kind of environment. So I think that would make a very interesting presentation topic if some of you are still looking. Okay, some other information about Linux if you want to know it. There is a really cool topics course at NC State called Advanced Computing. There's the website address for that course. They begin with an introduction to Linux. It's the first thing that they do. And there's some other websites too that might be helpful. Okay, any questions? Okay, so in order to run our R programs, we're going to have to run the programs in what's called batch mode. Has anyone by chance ever ran any kind of program in batch mode before? Okay, good, we got one. Back when I was a student, that was a lot more common to do. In fact, all my Monte Carlo simulations that I ran, which were all done in SAS, were done in a Unix. All my Monte Carlo simulations I did for my dissertation were run in a Unix environment where I used SAS in batch mode to run my programs. You can actually run R in SAS in batch mode on a Windows-based computer. I'll show you how to do that. But the main thing that you need to know, though, is how to run it on Tusker and Crane, because that's the only way, essentially, that you can run R or even SAS on the supercomputers. It's really not that difficult at all. But if you've never done it before, you might find it, you might not know what to do, and you might find it kind of awkward. So I think, though, after today, you'll say, okay, it's fairly easy to do. Okay, so what I mean by running something in batch mode, basically what you do is at a command prompt here, you simply tell you tell Tusker, hey, I want to use R, and I want you to run this program. So essentially you say, R, run this program. Tusker does it, and then when it finishes, it creates a file on in your directory that contains all your output. So everything that you would have basically seen previously in an R console window will actually be in a file. You can then download that file from Crane to your computer to view it. So if you want to know more details beyond what I'm going to introduce here about running R in batch mode, actually there's an appendix in the Introduction to R manual that comes with R that talks about it. Okay, so let's just simply look at an example here to get you started with it. As what's often done in many settings when you're learning a new programming language or a new environment to use a programming language, you type out a program called Hello World, where basically all you want is Hello World printed to your screen. Well, we're going to do a little bit more than that, but essentially that's what it is, so that's why I decided to call it that. So this is what my program looks like then in R. So I type this all in tin first on my own computer, and look at this, the cat function. I say hello world, then /n. Does anyone know what a /n does? It goes down to another line. Okay. And then what I decided to do to make this a little bit interesting is I simulate some data, and I'm going to estimate a simple linear regression model to it. All of you should be familiar with this kind of way of doing this, so I'm not going to go over it. And then lastly, what I want to do is a scatter plot of my data with the estimated regression line plotted. Now, if I were to run this regularly in R, my Windows-based computer, what would happen? A graphics window would pop up, and I would see my scatter plot with my line on it. Well, we are not going to have that available to us in Crane or Tusker. Instead, what we need to do is tell R, immediately put this plot into a file. And I'm going to choose a PDF file because that's typically, in terms of quality, the best. Or you could do a PostScript file, that would be good too. Oftentimes when you write a paper for a journal, they will ask you for a PDF version of any plot that you have created after the paper has been accepted, because it's typically the clearest format. In fact, for those of you who are familiar with my categorical data analysis book, all my plots in that were done by creating a file such as this and then including it then in my text. Yes?
This might be off topic, but when you say you're doing a presentation, what size of PDF do you generally use?
Well, I mean, I think by are you talking about the font size or
the size of the file?
You mean like 8 by 11 or?
Yeah.
Well, I think the default. Actually, I don't know what the default is. I would say it would default to 8 by 11.
Yeah. I put together a presentation, and some of the files take a long time to get into paper.
I think the default here will be the default size for the graph. So if I were to do this, if I were to run all this code in R here on my computer, let me just do that real quick, and plot it without using that PDF function, notice what will pop up like this. I think the default is 6 inches by 6 inches.
Okay.
And I'm assuming that there's probably some kind of default just like that if you were to create a PDF.
Okay.
Okay, so to tell R that I want to create a PDF file, I use a PDF function. Seems easy. And then I give it a file name. So this file, when it's created, will be put into the same folder, the same directory in Tusker where you are running your program from. You'll see that more when we actually run it. So I'm going to do the scatter plot. I'm going to use the curve function to plot my line. And then to tell R, hey, I'm done putting stuff in this PDF file, I say dev.off, which means device off. Okay. So that's what my program looks like. That is in the notes. Note that on page, eventually, well, it's kind of in the notes. I show you what the output file looks like. But you can download this program, obviously, from my website, too. Okay, so let's actually run this. So let me make sure I'm in the right directory here. Yes, I am. So to run this, then, I need to tell Tusker first that I want to use R. So I say module load R/3.1. I only have to do this once when I'm logged on. So if I keep on running R programs or other programs, I don't need to do it again. I only need to do it once. If I were to close out my PuTTY window and then log back into Tusker, I would need to do it again. Then I can issue the following command. I want to run R, so I'm going to do a R command, CMD, where I want to run R in batch mode. Excuse me, notice the capital letters. This is on page 30. And then I'm going to use a little option that I'll explain shortly called vanilla, dash vanilla. And then the program name. Okay. Now look what happens when I hit enter here. So watch what happens. You're going to see probably a little bit of a delay. Okay. So I had about a half-second delay before I got a new command prompt. That delay was because Tusker was running the program, and while it's running the program, you do not have
a command prompt that you can use anymore, which is can be not necessarily what's desired, especially if you have a long-running program. So a way around that is to use exactly the same set of commands as I just did. So I use the up arrow, and then I use ampersand, and look what happens when I hit enter now. Immediately I get a new command prompt. That 15872 corresponds to a particular number that Tusker has given for this process that's being run. If the process was still being run, and if I was able to look at this in top, you would see for PID, you would have seen that. Okay. Well, let's see. So, as I said, what will happen now is that Tusker has run the program, and it has actually created, let's see here, where is it? There it is. A file that's called exactly as what I just was running, but it also has another extension on it called .rout. Okay. Also, it's created a file called plot.pdf. Now I'm going to sidetrack here just to make sure I don't forget to tell you this. Let's see here. Okay. So at times you want to copy and paste text back and forth between windows on your computer and PuTTY. The way to do that, let's say that I already had typed out my command here. This is a notepad. Let's say I already had typed out my command. I can do Control-C to copy it. And if I come over here to PuTTY, and if I just simply right-click, it pastes it. You cannot do Control-V, as you might have expected. If I want to copy something that's already in PuTTY, I can just highlight it, come then over to a Windows-based document, and then right-click, paste. Okay, so you cannot do a Control-C and a Control-V inside of PuTTY itself. I just wanted to make you aware of that, because I know when I was first trying to do that, I found that frustrating. It's like, why can't I copy and paste like normal people do? So anyway, so now I like to take a look at my output. So the way that I would do that is I would go over here to my FTP program, my WinSCP, and I will sort by when were the files last changed, in terms of when were they last edited. And if you notice, in terms of my files, and I know this is kind of small, you notice plot.pdf was just created at 10. Let's see. Am I in the right folder? Oh, I'm sorry, let me refresh. Excuse me. Sometimes you have to remember to do that. I hit refresh, and now we can see that plot.pdf was created at 11:35. So, just about a minute ago. Hello world.r.rout was created at 11:35 as well. So now if I want to see these files, I simply open up a folder here, and I simply drag and drop. Drag and drop. So then now if I look at my PDF file, there you go, there's my plot. And if I want to take a look at my .rout file, this is just an ASCII text file, so you could open it up in various editors, even like Word. What my preference is to do is actually open it up in TIN. So I'm going to dock that. I'm going to dock this, and oops, actually I want to dock this over here. And so I'm going to open this up in TIN here by just dragging it over, and now there's my output that was just created. Okay. Notice it says at the very top, a Linux-based system was used. And you just see simply all my output that was generated. That's actually shown in the notes on page 32. You know, there are no really surprises in here. It will look just exactly what it would look like in our console window on your Windows-based computer. Now, by default, always, whenever you run something in batch mode, proc.time is always run. Because what that gives you is information about how long did this program take to run. So about half second. Okay, let me close some stuff out here. Let me make sure I save my order.r program as well. Okay. Let's make sure I talked about everything that I needed to here. Okay. So this is a comment on the bottom of page 30. By default, R will create a .r data file. If you're not for sure what .r data files are, you can actually create them in Windows-based environment. So if I were to, let's say, my R console, hit my X here to close out R, look what R asked me to do. Do you want to save a workspace image? I almost always say no. But if I say yes, in the folder where your program is essentially, I guess it depends upon your situation here. But what will happen is, if I say yes, a .r data file will be created. This will save essentially all the objects that you've created in R. Will save them to a file. Save them to a file that you can access later. I personally don't really find it useful at all to ever do that, so that's why I never do it. Cancel out of there. Okay. So when you run something in batch mode, by default, the .r data file will be created. If you don't want that file to be created, that was the purpose of doing the -- vanilla when I was trying to run on. So now .r data will not be created. Now there's an important advantage of making sure that .r data is not created. Because what will happen is, so if I would have done that, if I would have created it, you would see here a .r data file someplace in this directory here. Now the next time that I run an R program, and if I don't use the -- vanilla, let me just make sure I get that right. The next time that I run an R program, if I don't have the -- vanilla part there, whatever's in r.data will then be loaded into my R session. Now why is that a problem? Well, let's say that you're running a program and you discover there was an error. Okay, so now you need to rerun it, but you want to make sure that that error doesn't propagate in this next rerun. Well, you probably don't want to keep any of the objects that were created before. So that's why I never want a .r data file here. Now, if I did do the -- vanilla when I would run a new program with an r.data here, fortunately, off the top of my head, I'm not 100% sure now if R would automatically load the .r data. The main thing is never create one to begin with, and you don't have to worry about it. Okay? So it's all right. I just don't remember off the top of my head, but again, I never deal with .r data files, so that's why I don't necessarily worry about them. Okay. So let me make sure again, and I'm talking about everything that I need to do. Yep, I think I did. Good. Are there any questions? Yes.
Is there a difference between the R command batch and the R script command?
Well, thank you for bringing that up. On page 34 now, what we're going to talk about next is R script. Okay. So there's another way that you can essentially run an R program in batch mode, and that is to use R script. Before I get into the details of how to use it, I want to make sure that you fully understand all the different ways that are available to you to run R on just a Windows-based computer. So I'm going to show you a folder. Let's see. I know this is small, but this is the best I can do. So R is installed on my computer under Program Files, R, and then I just have up to 3.0.3 installed. And then if you look under the bin folder, x64, remember there's two different versions of R that are installed on your computer in terms of the, let me restate that. There's two different versions of R installed on your computer, one for 64-bit and one for 32-bit. Started a number of years ago. And so x64 corresponds to 64-bit. Okay? Hopefully, soon that people who make R will say, okay, we don't need to also install R32-bit too. So anyway, if I look under here, what you're going to see is a few different .exe files. These are executable files that you can use to run R. So right now on my computer, I have an R console window open. That corresponds to R GUI for graphical user interface. There's other ways to run R. In particular, R.exe does batch, the batch mode that we've seen so far. R script that we're going to talk about right now runs it. Essentially does a version of a batch mode, but in a little bit of a different way. And then there's some other ones too. So for example, if you use tin a lot, you'll notice that you have actually an R term window, which gives you another way that you can use R actually right inside a tin itself. I don't ever use it. So these are a variety of different ways that you have to use R. Let's talk about R script now. You have that available to you on Tusker and Crane. And in the simplest way that you can run R script is as follows. I can say R script, and then I'm going to use an option -E, this is at my command prompt, which says I want to send an expression, that's why you see the E there, in quotes to R and have the output immediately return to my screen. So there, I want a quantile, I want the 0.975 quantile from a standard normal, and I get 1.96 back. Another way to use R script is say R script, and then I put my actual program, hello world.r. And what will come back to my screen itself, is my output that we had seen previously in my .r out file. Okay. I think some people, and perhaps this is what you're talking about, you can, and you'll see this shortly, you can create what's called a shell script file, and you can actually run R through R script that way. Is that what you're talking about? Okay. So that will be another way that you'll, we're not going to do that exactly, but that will be one potential use for R script. I guess I have never found that to be as useful as the way that we're going to run programs, but that is an option. But specifically one of the reasons why I want to bring up R script is because if some of you have ever heard of the package knitter in R, or knitr, what knitr does, it allows you to embed R code and output inside of a LaTeX document, a LIX document, or an R Markdown document. If you don't know what those are, don't worry about it. But if you do, hopefully that's like, oh, that's interesting. You can actually embed R code inside there. And the way that this knitter package works is it uses rscript.exe on your computer to access R and then transfer the code that's run and the output that's generated back into your LaTeX or LIX document. So, anyway, let's see now. So also, R can be run in batch mode on your own computer. And I think this is more just out of curiosity why I'm going to show you this. So I'm going to get to a command prompt. Sorry, that's as big as I know how to make it. Let me see if by chance I can make it better. Maybe I can. It says, okay, we'll do with that. So when I go to an R command prompt, what I'm going to do is I use cd ... so I can move down a folder in Windows, cd again, and then I have created a folder called temp. And inside of temp, if I use dir for directory, used to be used with Windows 7, you used to be able to use ls. Now you can't anymore, you have to use dir. You can actually use dir in Linux too. And I have a listing of all my files that I have located there. And if I want to run my Hello World program there, I use exactly, and this is, I won't run it again, I don't think it's worthwhile. I can use exactly, essentially the same code that we used before to run it. It will run on my Windows-based computer. Notice since I didn't use a --vanilla, .r data was generated. And you can see that if you have, let's say, some large data objects, that the size of that file can be kind of large. It's another reason why not to use it. And so that will be another way that you can run R on your own computer via batch mode. Let's see now. Now do note that depending upon your computer and its operating system, in order to get this work, you might need to do some extra stuff. Set up what's called an environment variable. Take a look at this on your own if you're curious. Okay, so that takes us to page 38. Now, as you know, when you use R normally, you might have to download a package and install it. And of course, typically the way that you would do that, if I'm in the R console window, I could do packages, install packages. I get to a whole bunch of crayon mirrors out there, and I can pick my favorite one. I'm State University, and then a whole bunch of over 6,000 packages, at least right now, it's over 6,000 packages that will pop up, and I can choose the one that I want to install. That's the typical way that most people install packages. Now, if you were to do this still on Crane and Tusker, again, you don't have this nice Windows-based environment. And so you're going to have to use code to install a package. Let's talk about how to do that. Let me also, I guess before I talk about the functions to do that, we need to make sure that you understand where packages are installed on your computer. So on my Windows-based computer here, by default, under Users Builder, Builder's My Login, Documents, R, Win Library 3.0, you see a whole bunch of folders. These contain my packages that I've installed in R or via R, and that's where they're put. I never had to specify that location. In Windows, this is the default. When you use Crane and Tusker, you don't have access to the same kind of folder here that you would do in Windows. Instead, what you're going to have to do is set up your own directory to put all the packages in that you want to install. So what I do typically is, again, here's a listing of all my files. I create a directory called packages. So if I cd into it, you can see the various packages that I have installed on Tusker. Again, for emphasis here, this is on Tusker. So if I decide I want to use Crane, those are not going to be available to me. I would have to reinstall them on Crane. Okay. So at least the way that I have my stuff set up here, a blue font represents a folder, a black font represents an actual file, and a red one corresponds to what's basically a zipped file. When you actually run PuTTY yourself, the coloring system will be different. You'll be running the default, and I've just changed it via coming up here, change settings to something that I find more appealing. Okay. Okay, sorry, I'm kind of going all over the place here. So I have this particular folder or directory that I have created on Tusker where I install everything, and just helps keep everything nice and tidy versus installing in, let's say, the main directory that I'm working in. The two main functions that you need to understand or need to use to install R packages in on Tusker is use the install.packages function. This actually is what downloads and installs a package into a desired directory. And then also a function called .libpaths. Okay, think about the name. Library paths. In other words, where is that directory on Tusker that you are using for all your packages? And so what that does, it puts a particular directory on our search path. So R by default has a particular directory on Tusker that you do not have access to, that has the basic R packages installed. What I'm going to do is create a new directory that will contain the packages that I am going to install. And let's take a look at an example of how to do this. So this example involves the package Fortunes. Anybody used Fortunes before? It's one of the fun packages that are in R. It really has no useful purpose to it, but it's kind of fun, and I can use it in this demonstration setting. Okay, so here's my program copied directly out of tin. I wrote, again, all this code in tin. The first thing I do is I'm going to specify a path for R to put new packages. So I say new equal, and notice the directory structure there. Remember how this corresponds to where we started at the beginning of today when I showed you essentially kind of like a tree diagram that showed how everything was stored. So /work/stat_tool/builder, and then that new directory that I created myself called packages. And if you want to check to make sure that R recognizes it, just use the same function again but put nothing in there. Then to install the package, I say install.packages. PKGS stands for, well, what package are you interested in? I want Fortunes, so I put that in quotes. REPOS stands for repository, meaning what crayon mirror do you want? And I actually give the web address for it. So if you want to use something different than mine, you're going to have to figure out what the web address is. And then DIR stands for destination directory. Where do you want it to be? So I specify that there. And then if I want to use the Fortunes package, just like usual, I would say library package equal Fortunes. And there's one function in the Fortunes package called Fortune. And so let's look at how I ran this program. So I uploaded the program to Cream. If I hadn't already done this before, I put this here for emphasis. I would say module load R/3.1, and then I use R command batch -- vanilla install.r. After I run that program, and I happen to be in my packages folder, so notice here it shows packages right there. After I run that, I do an ls. And this is one of the first this was the first package that essentially I installed. And so based upon that, then I can see what happened. Here's my R output file. Here's the actual here's the actual file that was downloaded from Iowa State. And then this is the actual folder that was created after everything was installed. So let's take a look at my output file. Again, this is in tin. And here's my output file. And so you'll notice here's the search path. This is where R is going to look for packages whenever you want to use a package. The default is, again, the one that you do not have access to. This is basically in a folder where they've installed all of R. And then here is then my a place where I'm going to install my packages. So then when install.packages runs, you get some output that talks about, well, for example, 178K was downloaded from Iowa State. It talks about, well, was everything installed correctly or not? And then eventually it gets to the output. Okay, so what this fortune function does is this. Without any options, it will randomly select a fortune, you could say, from a database. This database actually contains a whole bunch of famous quotes written by our users, like for example on the R listserv or in other locations. And when I ran fortune this particular time, I got a quote from Brian Ripley, who's one of the R core members, and it says, this is actually from is it 2007? Really?
Mm-hmm.
For some reason I was thinking it was 2000.
The one in the notes is 2000.
Yeah.
It's a different quote.
Oh, okay, yeah, it's a different quote. So anyway, I don't like to see the use of C for its side effects. Well, Brian, you're a little picky. Anyway, I like the fortune that I ran that was in the notes, which comes from 2000 from Bill Venables, which says, SAS seems to be to statistical computing what Microsoft is to personal computing, in terms of it's essentially the default that you would use. This was back in 2000, which nowadays is not as much. Definitely, well, in terms of Microsoft, yes, but definitely in terms of statistical software packages. Okay. So let's talk about this this .gz file. Has anyone seen .gz files before? Okay. So this gz part, that extension stands for gzip. So all of you have probably worked with zip files before on a Windows-based computer. Well, there's a program called gzip that you can use on a Linux-based computer that will zip files. So it compresses them. How about a .tar file? Does anyone know what that is?
I've seen them, but I've never.
Okay. Often people refer to this as a tar ball. All this is a way to group files together into one overall file, essentially. Okay? So fortunes underscore 1.5-2 is a tar ball. So it was a whole bunch of files that were part of this package that was created, grouped together, and then to make it, let's say, easier for transport, the tarball was zipped. So it was compressed. So it's going to be a lot smaller file size than if you wouldn't have compressed it to begin with. And basically what this install.packages function does, very first thing is it will unzip it, and then it will expand the tarball, and then it will do some stuff to install everything. Note that here's my directory that has all my packages. You can see that it leaves the tarball zipped. It will leave that file in your directory. Again, the blue then corresponds to, let's actually take a look at fortunes. Oops. The blue is actually a folder, and this contains all the corresponding files from installing this package. Those files and those directories that you see there should look very familiar, because if I come over here to, this is a different package, but you see the same basic structure of, you have, well, fortunes is probably a bad example because it doesn't have any, it doesn't have some of the stuff, but it has help. It has HTML as a folder, it has meta, it has R, and it has some similar file names.
So, did you download 2 versions of fortunes?
Why do you ask?
Because one was 1.5.
Yeah, it looks like I probably installed it a few times. So you can still see the original stuff is there. And you can see eventually, depending upon how many packages you install, this could kind of clutter up stuff. Especially if you're installing packages that maybe have large data sets, you might want to consider deleting out the gzip file eventually.
And you could also just remove like the older versions that you've downloaded.
Yeah.
Right, just
Yeah.
like the first
Okay, so that's how you can install a package. Finally, now on page 41, we get to really the whole purpose of us using these supercomputers, and that is so that we can do parallel processing. And essentially, well, let's just use the same code that we used before with R. But we're just going to run in a different place. There's going to be some minor changes to take into account that we're running into a minor place, and I'm going to do a few things that are a little different just to demonstrate the capabilities of Tusker and Crane. So my actual program, which is not in the notes, is given there. Let's actually take a look at it. Let me remove some stuff here. So, oops, wrong one. There we go. So this is for the Monte Carlo simulations that we first were starting to do at the very beginning of the course. We're finding confidence intervals for sigma squared, and we're evaluating, the true confidence level. So the first thing that I'm going to do is simulate my data. I have samples of size 9. I have 500 simulated data sets. Everything, in terms of these simulated data sets, is in y.sim. So each row is one simulated data set. Now down here, actually I went too far. I want to use the parallel package first to do this stuff. And if you remember when we did this, we used the par-lapply function. And we had to specify basically the clusters that we're using, or I'm sorry, how many cores that we want to use, and that was set by make cluster. I put my data into X, and the way it had to be put into X was in a list format. So as a test, I'm going to run for 4 simulated data sets on 2 cores. So I say ysim, the first 2 rows for the first 2 data sets, and then y.sim, data sets 3 and 4. The function that I want to apply to each component of this list is per.core2. So if I come up here to per.core2, we see basically the first change to what we would have had in the last set of notes. The location of where this file is going to be stored. So now set WD for set work directory. I'm going to set it corresponding to where I have this file stored on Tusker. Note that I've created a new folder, again to make things nice and tidy, you could say, that will do all my simulations for parallel processing. And that's where I have run on each core.r. So to do this, I'm going to have to upload 2 programs to this directory, run on each core.r and this one here. Okay. So then the rest here is the same as before. I use the apply function to do all the calculations, and then I return all my intervals. And again, everything's the same. Let's see here. So if I go back to page 41, to get this program to run on Tusker, I again do module load r/3.1 if I had not already done that before, and then I run my program. Notice I put an ampersand there, because of course this program is going to take a few minutes to run. And I want to have access to my command prompt so I can do other stuff while I waited for it to run. So that's why I did that. While that program's running then, I issue top-u builder, because that will allow me to see what is actually running right now. Okay. Before I show you what looks like, let me show you the rest of this program here. So that was I've only shown you the test case. If I want to do all 500, which is also in this program, what I've done is I've set the same code up now for 1 core, 2 cores, 4 cores, and so on. I think I go up to 10 cores, 20 cores, 50 cores. Once I get up to about 10 cores, I do something a little bit differently in terms of how I put the data. In terms of how I put the data into par-lapply,
And we'll probably just talk about that next time. But let me come back here. Here's what, when I knew that there was 10 cores being used, this is what top looked like. So you see a bunch of R commands that are running. So again, notice under this S here, which I think stands for state, it says that I am running R using essentially almost 100% of the CPU. This actually corresponds to a core. So I have one core that's running at essentially capacity, another core that's running at capacity, and so on. This also gives me my percentage of memory that's used right now to do all this. Down here you see another R. And notice it says S for sleeping, and it's not using any of the CPU. Remember how we did parallel processing on a Windows-based computer? Basically, when I do par-l apply, it basically spawns out new R processes, or new R instances, you could say, and it runs it in the background. And so when we were looking at that in the task manager, we would see, if I had 10 cores on this computer, we would see 10 versions of R running, separate versions of R running, and then we would see another one that basically corresponded to my R console window, where all the results would eventually return to. That wasn't really being run right now. And so what we are seeing here is essentially the same kind of thing happening here on Tusker. So the R down here is my original version of R that was running my program. And it's just waiting for the other versions of R to get done. Let's take a look at a summary of me running all these different, running this program using different number of cores. So I have the program set up so I'm timing everything. And you're going to have to do the same kind of thing in your assignment. And so you can see if I use just one core, my program takes about 16 to 17 minutes. Then when I go down, when I use 2 cores, about half as long. And you can keep on going. Things start to level off about at 10. You can see 20 here and 50 there. Remember, I have 64 cores available to me. Excuse me. On Tusker, on one node. So we're only talking about one node here. And so you can see that you're not decreasing anymore. Well, why? Well, there are other things that are going on in the program that are always going to take some time, no matter what. So you're not going to be able to get down to 0. I was kind of surprised, though, to see once I went up to 50, the time actually went up a little bit. And probably the reason why, and I don't know 100% sure, but probably the reason is that I'm asking for 50 of the 64 cores to be run. Maybe some of the other cores were being used by others. And also, still, all these cores have to communicate with my main core that I'm running everything on to begin with. And the more cores you're using, the more communication time you're going to have. And so I'm not really concerned about that, but that is what happens. Or what happened here? Okay, we are basically out of time. Are there any questions? Now, to do the assignment, and in terms of on Crane, you're not going to be running R exactly the way that we're running here. And if you want to get started on it over spring break, read ahead on page 46. We talk about how to use what's something called Slurm, which is a different way that you can essentially start your R programs running on Tusker or Crane. That's how you need to actually run your programs. If you read the section on Slurm, you'll see why that's recommended. Well, I'm running R in this manner first because it's easier, and this is often what you do when you want to test programs out to make sure they run before you run them, let's say, for real, for a Monte Carlo simulation maybe that you're doing for a group. Okay, any questions? Okay, see you next time.